Hello everyone. Welcome to my talk on updates on distributed file system access via the new VFS. As you can see, my name is Anoop CS and I am a Samba team member. I work for IBM as part of my daily job. Unfortunately, I couldn't travel due to some unforeseen circumstances and has decided to go with a pre-recorded talk. I hope it all goes well. Here is what we're going to discuss over the next couple of slides. I would like to start off with a quick recap on Samba's VFS, the old and new structure with a bit more focus on changes done over the last couple of releases for modernizing the VFS interface. Then we go through a GlusterFS case study as an example for distributed file system interaction via Samba's VFS. Following that, we look at various changes the VFS module for GlusterFS has gone through to align with the new VFS interface from Samba, along with a glance over some bugs and improvements in this process. Next, we analyze some performance numbers for specific test cases and how these changes have taken its toll. And last but not the least, an explanation on our automated integration testing infrastructure to reliably find and fix breakages in a fast-moving upstream. So without wasting much time, let's roll. The new VFS, a recap. The Samba VFS provides a mechanism to allow people to extend the functionality of Samba in many useful ways. To name some are like converting NT-ACLs to preferable ACL format supported on a target file system, or even full NT-ACL support by storing them in an exadder, implementing alternate data streams, and not to miss the support for user space distributed file system, and so on. A Samba VFS is a shared library that implements some or all of the functions that the Samba VFS interface makes available to provide the desired functionality. As a result, we have various interfaces corresponding to different file system APIs to have a smooth interaction between both ends. When we check internally, all those interface logics operate on paths, especially in SMB1 case, it's purely on paths. As far as Samba is considered, it is necessary to process these paths to make it easier on UNIX platforms. Thus, it is very complex and slow. To mention some examples are char-set conversion, name mangling logics, case-insensitive semantics, previous version support, named streams, etc. I still remember various functions as large as thousands of lines of code. If we look more closely at Samba sources, internally we had a file handle structure called struct file struct, and all variables pointing to objects of such type are typically called FSPs and are normally returned after a call to SMB VFS create file interface. This SMB VFS create file interface boils down to enormous number of lines of code afterwards, including NTFS simulation and much more. And on top of all, we had the long-standing CV related to symboling races, for which I can only recommend Walker's and Jeremy's talk from previous editions of sambaXP. They have explained the problem with symbolings and Samba in minute details, and I don't want to repeat it here. So all these enabled us to rethink on how deeply Samba is internally dependent on paths, which finally paved the way for a new VFS on a handle-based approach. In contrast to SMB1, SMB2 and Plus is a purely handle-based protocol. Please note that SMB1 is already deprecated and is disabled by default within Samba from version 4.11. Here the idea was to streamline the VFS interface to be mostly handle-based. SMB2 create is still a request with path name intake, and everything else operates on handle returned by SMB2 create. I would like to mention the major challenge as mentioned by Ralph 2 years back in his talk on Road to New VFS regarding the required permissions to open a file handle on Linux, which is O read only. Thus, doing an open with O read only would require R permission on the file, that is the read permission. Then came the lifesaver flag or path flag, which can be used to open a file, returning a handle solely meant to act as a path reference. These file handles cannot be used for I/O operations. Compared to O read only, OPath doesn't require R permission on the file, rather an executable permission on the parent directory. Internally, a new function was groomed to implement this logic named openat pathref FSP, which skips the NTFS emulation part and finally calls SMB VFS openat interface to open an FD at file system side. In this context, we started using the at variants of various syscalls to operate relative to mentioned working directory rather than full path names. Necessary fallback mechanisms were also introduced to cover the cases where OPath flags were not available with specific file systems. At this point, I would like to stop with the recap of old and new VFS implementational blocks and bring your attention to a particular category of Samba integration, that is with the distributed file systems. Here, as an example, we analyze Samba's interaction method with GlusterFS and further get into changes to upgrade the module to match with the new VFS interface for better integration. So GlusterFS. GlusterFS is a distributed file system defined to be used in user space, that is file system in user space. It is scalable, flexible and completely open source, designed to run on any file system with extended attribute support. Various features of the file system include replication, quotas, snapshots, geo-replication and more. Basic building block of GlusterFS is called a brick. It is basically any directory that is meant to be shared among the trusted storage pool. Based on the configuration and how bricks are spread over various nodes in the pool, we have different volume types like distributed, replicated, dispersed, etc. A combination among these volumes are more commonly deployed in clusters. GlusterFS has its own fuse module integration with which it can be mounted locally on a client machine. On top of that, access via other protocols like NFS, SMB are also in place from a long time. Especially for SMB protocol access to GlusterFS, via clustered Samba, we make use of CTDB, where a dedicated no data volume is used for holding the recovery lock or cluster lock. Nowadays we call it as cluster lock on a file. Now let's look into some details on how Samba integration with GlusterFS is implemented via VFS interface. At present, we have two methods to interact with GlusterFS. Two different VFS modules are specifically built for this purpose, namely VFS GlusterFS and VFS GlusterFS Fuse. In VFS GlusterFS, entire flow happens with Gluster's native C API called libgf API. libgf API contains almost all required file system APIs for storing and accessing files from GlusterFS, that is the distributed file system. GlusterFD, which is known as GLFD, is the file handle that is meaningful to GlusterFS. This GLFD is co-located with Samba's FSP structure internally and is stored as an FSP extension using the standard VFS add FSP extension macro. As we see with other VFS modules, VFS GlusterFS also has its own configuration options, which includes the volume name, path inside the volume to be shared, GlusterFS client log level, its location, etc. These can be mentioned in respective share sections in smb.conf, where GlusterFS module is configured in VFS objects parameter. Within the module, we also have some additional logic to better cope with the extra VFS interfaces provided by Samba. Most common example that I can highlight here is the SMB VFS getRealFileName implementation to perform a case insensitive search for a file name in the file system. GlusterFS has developed its own mechanism just for Samba to speed up the file creation. Having said that, we are still stuck with the growing memory resources, with more and more clients getting connected to Samba backed by GlusterFS. This is due to the fact that the entire GlusterFS client stack being loaded into each forked SMBD process for every client trying to access the file system. In those cases where large number of clients are connected, we could switch to the other model where a local fuse client mount of GlusterFS on server can be reused for various clients. In this case, Samba can work like a local file system beneath it with no additional configurations required. We do have it separately as a VFS GlusterFS fuse module, as it also implements additional logic for getRealFileName, and on top of that for unique file IDs also. So that's all about integration and how it's organized. With changes to Samba's VFS to take a handle based approach, VFS GlusterFS also had to go through various modifications. Let's take a look at those changes. Before that, I would like to mention about the @variants for different APIs, which are key to building handle based approach in Samba's new VFS. libgf API added support for @variants of almost all required APIs from Samba with major version 11. These were introduced with bare minimum test cases to ensure that existing mechanisms are not affected. These additional APIs have one-to-one correspondence with their respective system calls. Since these are relatively new, we can't consume it blindly. Therefore, these changes were made accordingly to conditionally include or consume those @variants whenever they are present. This is done with the help of #ifdefs to check the particular version of libgf API. You can see the number 7 as a prefix to the major version number, which is present from a long time, and it is still required to determine the GF API version. So you can see that everywhere in the source. So within Samba, VFS GlusterFS source file is located at source 3 modules VFS GlusterFS.c, and the @variants were basically added via the merge request that is already linked in the slide, merge request number 2682, which consumed almost every required GLFS @variants for various APIs in VFS GlusterFS. So the OpenNet call was the most prominent one to be carefully changed. So if we take a look at the source, you can see that there are various if conditions all throughout the OpenNet system call. So the if conditions are basically used to detect whether OPAuth support is available or not, and there was a special OCreate section where a OCreate flag was handled differently, and also to differentiate between various versions where these @variants of the calls are present or not. So there are various if defs you will see in the particular OpenNet implementation in VFS GlusterFS. In all other calls, we fetch the parent GLFD. So whenever we operate with handle based approach, we need to fetch the current working directory or the parent directory, and then operate on the required GLFD. In calls like mkdir, rename, link, fstat, fstat, in all these kind of calls, we will see a fetching of parent GLFD and then making use of the real FD to operate on. In other calls like fstat, fchmod, fset, etc., we directly access the GLFD from the FSP extension and operate on it. So let us look at some bugs and corresponding fixes and some improvements that we have made all throughout this journey while making the changes. Even well before these at variants were introduced, from the GlusterFS side, we had a bug within getRealFileName implementation where Samba already switched, but corresponding changes were not made in the implementation within VFS GlusterFS. So there we could fix it with the older implementation of constructing the full path name instead of file handle, and it was fixed in that way. Next is the oCreate special case. So basically in GlusterFS API, which is libgf API, there was a bug inside the implementation for OpenNet where whenever there is an oCreate flag present in the open code path, it was not treated correctly. As a result, creation of file was failing. So we fixed that in GlusterFS side. You can see those hyperlinks there. They are hyperlinks, so you can get the details from those links. It was basically a failure to link the inode when the file was created. So we fixed it at the GlusterFS side, and it's working right now. And the next section was a series of ebadf errors, which are basically, as I mentioned a few slides back, the file handles that are obtained with OPath flag cannot be used for any kind of modifications on the file, like any IOs or any metadata modifications also. So these were done unknowingly, and we used to see all kind of ebadf errors at the GlusterFS side because those were not conditionally called from VFS GlusterFS. The first case was VFS getRealFileName. Previously, in the first bullet point, we already fixed it even before the implementation happened in VFS GlusterFS. Now that we have switched to GLFS OpenNet, we have to again change it back to the handle based approach. So that's what we did. And also with SMB VFS getExatter, we had to differentiate between the usage of GLFS getExatter and GLFS fgetExatter. In the later case, we have to fetch the GLFD from the FSP extension. Another one is related to SMB VFS FN times, where we fixed a similar issue when we encountered a ebadf error. Now let's take a look at how it impacted the overall operation of the VFS integration. So on the performance side, the data that we are going to see, these are the metrics that I have used. Use cases here are for creating large number of files in a directory like a 10K empty normal files and listing that particular large directory. Versions that we have used here is the latest master from GlusterFS, and compared, keeping it as constant, we are comparing it with various versions of Samba: 4.18.2, 4.17.7, 4.16.10, 4.15.13, and also 4.14.14. So this is done basically to see how the change to the new VFS have impacted the overall performance. And the type of volume used here is a distributed replicated with arbiter volume. That is basically a 2 cross 2 plus 1 volume. And it is spread over 2 nodes which are not clustered from Samba's perspective. That is, CTDB is not used. And from the client perspective, we are just using the SMB client utility and the related tools like SMB control to get the profiles and to switch the profile on and off, and SMB status to dump the profile statistics. So here is the create statistics. So from left to right you will see the different versions, and from top to bottom there are various metrics like the openet count and also the total time taken. Similarly for close, stat, fstat, real path, chdir, and also the total time taken. And you will see 3 different colored numbers all throughout the table. So I would like to start from right to left basically. So if you see in version 4.14.14, which is the latest from 4.14 branch, the open count is around 10,000, and it kept on increasing as we move above from 4.14 to 4.15 and all the way till 4.18. So the increase throughout all these versions we had these changes related to new VFS coming in, and that's why we see extra number of opens, basically doubles it. So, and correspondingly for close, but for stat we see that it has considerably decreased after 4.16. fstat count is almost constant in all of these 4 versions, for 5 versions, and the real path count has also considerably decreased, similar to stat count, and chdir also has decreased after 4.16. And if we take a look at the total time taken to create 10K files, empty normal files in a directory, it was around 1 minute with 4.14, and when the changes came in for the VFS reorganization, it jumped to around 25 minutes or 26 minutes from 4.15 to 4.18. So this is considerably large, as you can see from the table. It has come up to 28 minutes on 4.18. But on listing those 10K files created previously, we don't see much change in the count. Basically, if you look at the various numbers for count, for openet, close, or stat, we don't see much difference in the count. And the total time taken here is almost 20 seconds to list the 10K files, and it is constant, it doesn't vary much. That's all about the performance numbers. Now let's take a look at the testing side, how we test this integration. So we all know that it is a fast moving upstream. A lot of changes come in every now and then. Thus, it is necessary to keep up with these changes in a periodic manner. Otherwise, we go unnoticed about any breakages. For Samba, we do have GitLab runners with a dedicated pipeline for every merge request against main repository, but they don't yet run any tests over VFS modules like VFS GlusterFS or VFS FFS. In order to reduce any breakage gaps, we started with this project called Samba integration under Gluster namespace in GitHub. Our main intention was to find any breakage as soon as possible in upstream before a release branch is cut on either side. As a result, we ended up having a Jenkins-based pipeline on CentOS CI infrastructure. The CentOS CI infrastructure is sponsored by CentOS for various vibrant and active community projects. I am glad to say that Samba is one among them to have a dedicated namespace in this OpenShift based cloud platform. For every run or for any failure, we get an email notification which are configurable with links to logs. So at this point, whenever there are failures and we are notified, we are supposed to debug, discuss and propose fixes to turn these jobs back green. Currently, we have two kinds of jobs configured to run as nightly jobs. They are the RPM build jobs and integration test job. RPM build jobs are periodically updated and configured to run on supported release branches and master. When I say supported release branches, I mean those branches with hyphen test suffix pointing towards the next minor version. So basically these are the branches with a moving head. Packages built are uploaded to an artifact server from which they can be easily downloaded. For easiness, repository file is also provided to be configured in RPM based distros. Next category defines the integration job for GlusterFS, where we have very minimal subset of SMB2 torture test chosen to run against replicated and dispersed volumes. So this is how it looks like on the web page. This is the Jenkins instance here, and you can see various jobs listed. There are sections for RPMs and integration with Gluster. Yeah. So moving forward, we decided to split up the repository into different repositories, categorizing the content. And along with that, we found a new home under Samba in Kubernetes organization. The whole content to set up the testing environment was split into a new repository called SIT environment, and test cases and related framework now reside under SIT test cases. RPM build job related sources now constitute Samba build repository. All Jenkins and OpenShift related infrastructure configurations form the Samba CentOS CI repository. Next step is to add SFFS integration testing, which is exactly similar to GlusterFS. As we shift our focus to SFFS, now we plan to cover almost all tests that we do now with GlusterFS. As a result, we have few fixes already identified and are merged upstream. One such merge request is already linked in the slide, merge request number 2939. We expect more failures and fixes to come in future. In order to prepare our SIT test environment to accommodate different backend file systems, we now have a large change proposed to modularize the current GlusterFS tasks. That is also linked as a pull request in this particular slide, pull request number 9 from SIT environment repository. This will help us in future to easily plug in VFS related setup instructions. So let's get a gist or summarize and look at the takeaways from what we have discussed all this while. So all these new VFS changes and the current VFS GlusterFS, everything works. The handle based new VFS approach is now robust and secure. Distributed file systems, since we have discussed GlusterFS, is now nearly compatible with new VFS structure. I would say nearly because there are still some areas or some APIs which lacks some modifications, which will be done in the coming months. At variants of different calls were introduced, and they are working without any failures. We discovered various bugs and came up with some nice improvements. Performance penalty is a concern and are to be looked at in future. We also looked at the automated process based on Jenkins from CentOS CI infrastructure, which is configured to find any failures or breakages with this integration. So with this, I conclude. Please don't hesitate to contact via email, metrics or IRC as mentioned here for any clarifications. Have a great SambaXP time and thank you.